Isomerism is the phenomenon where two or more compounds have the same molecular formula but different structures or arrangements of atoms, leading to differences in properties. Types of isomerism. First, we have structural isomerism, also known as constitutional isomerism. In this type, isomers differ in the connectivity of atoms. There are several types. Chain isomerism. This occurs when compounds have the same molecular formula but different carbon chain arrangements. For example, C5H12 can be pentane, 2-methylbutane or 2,2-dimethylpropane. Position isomerism. Here, compounds have the same carbon chain but different positions of functional groups, multiple bonds, or substituents. For instance, C3H8O can be propan-1-ol or propan-2-ol. Functional isomerism occurs when compounds have the same molecular formula but different functional groups. For instance, consider the molecular formula C3H6O. This can represent two different compounds, propanol, which is an aldehyde, and propanone, which is a ketone. Metamerism is a type of isomerism where isomers differ due to different alkyl groups on either side of a functional group, such as oxygen, nitrogen, or carbonyl. For example, the molecular formula C4H10O can represent ethoxyethane and methoxypropane. Tautomerism involves a dynamic equilibrium between two isomers that differ in the position of a proton and a double bond. A classic example is keto-enol tautomerism in acetone. The chemical equilibrium can be represented as CH3COH3 in equilibrium with CH3COH, CH2. Stereoisomerism. Here, compounds have the same connectivity but different spatial arrangements of atoms. Geometrical or cis-trans isomerism is found in alkenes and cyclic compounds due to restricted rotation around a double bond or ring. For example, butuene can exist as cis-butuene, where the same groups are on the same side, or trans-butuene, where the same groups are on opposite sides. Optical isomerism involves compounds that rotate plane polarized light due to Chiral centers, which are asymmetric carbon atoms. Optical isomers exist as dextrorotatory, or D or plus, which rotates light to the right, and levorotatory, or L or minus, which rotates light to the left. For example, lactic acid, TH3CoCo, has two enantiomers, which are mirror images of each other. To conclude, isomerism is an essential concept in organic chemistry that explains the existence of multiple compounds with the same molecular formula but different properties. It is categorized into structural isomerism, which involves differences in atom connectivity, and stereoisomerism, which involves differences in spatial arrangement. Understanding isomerism helps in studying the diverse behavior of organic compounds.